going so far? How's your semester going so far?
Yeah,
Chaos?
good.
Good?
Yes.
It's chaos by me.
Getting busy, doctor.
Getting busy? I already busy. I promised you to do some videos and whatnot, but I haven't done it. I have prepared the material, but I haven't recorded the video yet. But as of today, it's still okay because chapter 1, this is number system is chapter 4, right? Module number 4. Yeah, module number 1 until module number 3 is the revisit of the digital electronic. So you have heard that topics once in the first year. It's just a revision of that. It's okay, but starting from these topics, the number system, you can see my screen, right?
Yeah.
Okay, starting from this chapter will be a new thing for you. Wait, before that, I remember last class, maybe last Thursday, last week, we talked about yeah, I'll do the poll for you. I'll do some poll. What was it about? I don't remember.
To start at 8:30 or to start at 8 a.m.
Oh, okay, it's not a big deal. Yeah, it should be 8:30 because I think I'll take my breakfast at 8. How about you guys?
Sounds good to me, doctor.
It's better.
Yes.
Right? Okay. Because 8 is too early. Okay. Back in my uni days, we start class at 8:40. The first period is 8:40. So I'm not really familiar with this 8 a.m. system. All right. So I hope we can all enjoy our breakfast before getting to the class. Okay. Or morning class for Sunday and Thursday. All right. You guys ready? You have to take notes, yeah? Because there will be a lot of calculation in today's lecture. Right? Okay. So today we're going to learn about the number system in the digital system. Right? Okay. Before we start, let's has a warm up with a set of number system. This is not really important for this course, just for the warm up, the first slide of the day, right? So we have learned, okay, when we are kid, when we're born, we learn about a natural number. What is a natural number? A natural number is a number that is positive and it can goes up to infinity. So 1, 2, 3, okay, 0 not included. So 1, 2, 3 up to infinity. That is called the natural number. Natural number. Okay. So the natural number is a set of number. We call that a set of number. A set of natural number is 1, 2, 3 up to infinity. And then when we add 0 to the set of natural number, it is called the whole number. So the whole number is 0, 1, 0 until n to the minus 1 for the magnitude. Here. So the sign bit is not count. The MSB is not count in the sum of magnitude, right? Yes. We also multiply this with the sign bit. Okay. Negative -, to the power of sign bit. So if the sign bit is 1, so this magnitude will be negative. If the sign bit is 0, okay, -1 to the power of 0 is 1. So this number will be positive, right? Let's see example here. We have 1010. So we know that the sign bit is negative. So this will be a negative number. Okay. And in this course, we write SM for sign magnitude. Like in binary, you write 1010. Like that. This is the unsigned binary. When we want to write the sign magnitude binary, we write it as 1010 SM. Sign magnitude. Okay, so we calculate here the sign and the magnitude. The magnitude is calculated as 2 and the sign is -1 to the power of 1 because the bit n minus 1 here, or the MSB here, is 1. Okay? The bit value itself, not the position, but the bit value itself is 1. 1 here. So the answer is -2. Okay? Any questions? Any question, everyone? No question? No, okay. So it's easy, right? The sign magnitude. All right.
So far, so good, Doctor.
All right. Thank you. All right. So now we're going to see the ones complement. Ones complement. Okay. So in ones complement, can you see the full slide? In the sign complement, we flip the number to make the positive value. So the positive number in the ones complement is represented the same way as the sign magnitude. We have the sign bit here, 0, right? Sign bit here, 0, and then we have the magnitude. Okay, we have the magnitude. And then for the negative number, okay, it's just the respective positive number. Respective mean so we just take positive 2 to make negative 2. We just flipped the positive 2 to make negative 2. Okay. We have positive 2 here, right? So the positive 2 is 0, 0, 0, 0, 0, 0, 1, 0. So we flip this number to make a ones complement of negative 2. The negative 2, right? So the negative 2 is 1, 1, 1, 1, 1, 1, 0, 1. Right? So that's easy. So how can we calculate the value for n bit ones complement, right? So what we need to do is we calculate the MSB as negative. So you add negative here, the MSB. So this is the bit of the MSB, and then this is the weight of the MSB, right? -1. And then you add that with the summation of the remaining bit, means you exclude the MSB. Okay? and this is the remaining bits. Then you add the MSB bit. So add 0 or 1 of the MSB bit. This one. Okay, let's see example. We just calculate the weight, okay, the value of MSB, but make it negative number. So here it's negative 8. And then you calculate the remaining bits. Okay, that is in green here. Calculate the remaining bits. Here is 1010. The remaining bits here is 2. And you add the MSB bit value, okay, the bit value, which is 1. So you get this value, this 1's complement value, or we also write it as 1C. 1C. We calculate it as minus 5. Okay. And sometimes it is easier to just flip the number to find the magnitude, right? So you have seen the MSB here is 1. So you know that this is negative. So the sign must be negative. And then you flip it back. Okay. So you flip 1010 to get the value 0101. And you can have minus 5 here because 0101 is 5, right? So the sign is negative and the magnitude is 5. So this could be easier to find the value. But the equation to find the value is this one. Okay. The MSB is negative, and then you calculate the summation of the remaining bit, and then you add the bit value of the MSB. All right. No questions? Questions? Any questions?
No.
No?
Yes.
Excuse me, doctor.
So far, so good?
Yes.
Hello, doctor.
Yes, questions.
For the last slide,
Last
the
line.
slide before this one. Yes.
This one?
The slide, last slide.
Last slides?
The previous slide. Sorry.
What?
Okay, yes, this one. For the 8 ones, does it have a meaning? 1111, 1111.
It will be like minus 0.
Okay.
Right?
Okay.
Because the negative number is the respective positive number flip. So the 0 here flip, all 0 flip will be 1111. Right?
You're right. Thank you.
Okay. Okay.
So, doctor, what does the one's complement mean, or what's it used for?
Both all sign magnitude 1's complement and 2's complement is used to show the sign number of binary. Okay. But different system is using different way to shows the sign magnitude. And the most used one is the 2's complement, like in your computer now, in your handphone. Okay, most ICs now is using the 2's complement. But back then, there are also systems that is using the sign magnitude and also 1's complement. Okay. Okay. Why we are using 2's complement better than the 1's complement and the sign magnitude? It's because it is easier to do arithmetic, which is the subtraction. Okay? Because by adding numbers with the 2's complement, that is equal to doing a subtraction. So the computer is using the 2's complement. right?
Okay.
All right. Okay. No questions on this one. So far, so good, right?
No questions, doctor.
Before we end the class, we will combine everything and we'll do some exercise. Okay. So that we'll see whether you get confused or not. All right. Next, we're going to see the two's complement. Okay, the two's complement. Okay. So in two's complement, we add one. We add value 1 to the one's complement. So for 8-bit two's complement, the range is from 128-bit to minus 128 to positive 127. Right? And the positive number of one's complement is represented the same way as the sign magnitude. Okay, same way as sign magnitude. But the negative number, that is including all ones here, okay, is the respective positive number of the one complement plus 1. Okay, add 1 to it. Okay. For example, let's see the positive 2 here. Positive 2 in the two's complement is 0, 0, 0, 0, 0, 0, 1, 0. How do you know that this is positive 2? Because the sign is positive and the remaining bits are showing 2. Okay, the remaining bits value are 2. So this is positive 2. Okay. And if we flip this number and then we add 1 to it, so we flip this number to be 1, 1, 1, 1, 1, 1, 0, 1, and then we add 1 to it, we will get the negative 2 of the two's complement. So you see the sign bit is 1, sorry, the sign bit is 1, and the rest is the rest is the magnitude that is added 1 to the one's complement. Okay. Or alternatively, okay, the easiest way to find the two's complement is by you start from the LSB of the positive 2, which is 0 here. So let me write this again. Positive 2 is 0, 0, 0, 0, 0, 0, 1, 0. So to find negative 2, okay, you start from the LSB, which is 0. Okay, start from here, from the right, okay, the most right. And then write the bit, just copy the bit until you reach the first one. So the next bit is already the first one. So this is the first one, right? And then you flip the remaining bits on the right. So you just flip the others. 1, 1, 1, 1, 1. So you get this. Okay. The negative number in the two's complement. You will get the two's complement of 2, positive 2. Okay, let's see the other example. What is the two's complement of 1, 0, 1, 1, 1, 0, 0, 0? You just copy from the LSB to the first one. Okay. From the right to left until you reach the first one. Okay. So these bits stay the same. And then the remaining bits, okay, on the right, you have to flip it. You have to flip it. So these bits are flips. Right, so this is the 2's complement of this binary. This is the 2's complement of this binary, or this is the negative version of this binary. Okay? Any questions, everyone? So far? No? No question?
Sensei, the
Yes, yes.
2's complement and the 1's complement only applies for 8-bit, is it?
No,
Or can it go beyond that?
it can go beyond that.
Oh, I see. Okay.
It's just that the example that we use here is 8-bit.
Sensei, may I ask a question?
Yes.
Yeah, as you the example you gave just now,
Mhm.
the 2 complement of that number, that number is from sign magnitude or 1's complement. That one.
This one?
Yeah, that one.
Oh, this one is the normal binary.
Oh, normal binary.
Mm.
Normal. That means there's no sign.
Unsigned.
Unsigned.
So if the question just asks like, what is the 2's complement of the unsigned number, then this is how you calculate it.
Then shouldn't be another extra bit for indicate there is
The sign.
yeah, is it positive, right? That unsigned number.
So if
It
we have
shouldn't
0 here, then we have 1.
Oh,
So beyond this is 0, right?
yeah.
0, 0, 0. So it will be like 1, 1, 1, 1. So this is negative number. Good questions. You'll check. So this is a negative number. 2's complements shows the positive and negative number. Beyond this is 0, 0, 0, 0, 0, and it will be like 1, 1, 1, 1, 1. So this is a negative number.
Oh,
So when
still a
we
bit confusing.
That's the
but never mind. I will digest later maybe.
Okay, this is just like how you change the 2's complement generally in general.
Yeah,
So when we want to use
plus 1.
when we want to use the 2's complement in the system, we have to specify what are the bit values that we want to use. So if we want to use an unsigned number, when we want to use unsigned number, we don't have to mention this unsigned number is how many bits. Okay, the MSB is at which bit. But when we want to use the signed number, we have to mention this is how many bits signed number, so that we know where can we find the signed bit. So we want to know what is the MSB and where is the MSB. Very good questions. Thank you very much.
Thank you, Sensei.
All right. Okay. Any more questions? Okay. So I'll continue. All right. Now is how to calculate the value of 2's complement, right? So we have the MSB here will be negative, and then the sum of magnitude here. And the sum of magnitude is the sum from bit at position 0 until n minus 2. Okay, remember to exclude the MSB. Exclude the MSB because MSB is the sign bit, not the magnitude. So that is how you calculate the value of 2's complement. So for example here, if we have 1, 0, 1, 0 here, okay, calculate the MSB as negative, and then the rest of the bits, the remaining bit, positive sum, and you will get -6. So if you know that the MSB is 1, so you already know that the sign is negative. And what you do next is to use the alternative method, okay, to find the magnitude. So the alternative method say from the right, from the LSB, okay, write it again until you reach the first one, okay, the first bit one, and then you flip the rest. Right? Okay. If I have another example here, or this complement. Okay. For example, if we have 1, 1, 1, 0, 0, 1, 1, 1. So we want to know what is the value of this 8-bit 2's complement, right? We can calculate using this. This is minus 2 to the power of 8 plus 2 to the power of 7 plus 2 to the power of 2 to the power of 7, 2 to the power of 6, 2 to the power of 5, 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. Or if you are familiar with the positive number, see that the MSB is negative, and then you just write the number. You write the number back, which is 1, and then flip everything. Okay? So this is negative. In plus 8.
25.
Negative 25. Okay.
Yes.
So it is less number to compute. So it's 3 instead of 1, 2, 3, 4, 5, and 6. Yeah. Right? Understood, everyone? Okay. So you just use the alternative method here. You just follow from the LSB, just follow until you found the first one. So in this case, the first one is at the LSB. So you write the first one, and then you flip everything. Okay? So it's not that hard, isn't it? Question?
Yes, very easy actually.
Easy, right? Okay.
Yes.
So I have meeting at 10. So I want to conclude the topics here, but we still have a few to go. We still have a few to go. But we will go to fix and the fractions on the next class. Okay. But the calculation part is done to here. So let me see. I want to do some example. So we have done a few example. I want to do another example. If I can use a whiteboard, for example. All right. Okay, so let's take one example, which is 39. So we want to find this in the sign magnitude. Then 1 complement and then 2 complement. What is the positive 39 in 8-bit sign magnitude? We have 32, which is 2 to the power of 5. Then remaining is 7. So 2 to the power of 2 to the power of 1 and 2 to the power of 0. Am I correct? So it's 1, 1, 1, 0 in 8 bits. 8 bits. 1, 1, 1, 0 from the right, 1, 1, 0. And then 0.
0, 1, 0, 0.
1,
1,
0,
0, 0.
0. Right? So this is the
The
positive
binary number
39.
for 30.
Positive 39.
Yeah.
Right? Okay. So the sign magnitude, the ones complement and the twos complement is the same for the positive 39. Right? Okay.
Yeah.
Am I correct?
Yes.
So for positive 39, 0, 0, 1, 0, 0, 1, 1, 1. Then ones complement is 0, 0, 1, 0, 0, 1, 1, 1. Twos complement is also 0, 0, 1, 0, 0, 1, 1, 1. Okay. But what about minus 39? Minus 39 in sign magnitude is?
We'll change the 0 to 1.
1.
Change the
MSB.
MSB, right? Change the
MSB,
MSB to 1 and the remaining bits
Will be the same.
will be the same. Okay, will be the same. So it's 0, 1, 0, 0, 1, 1, 1. So we just change the MSB for the sign magnitude. For the ones complement, minus 39,
Um,
Flip the number.
flip the number. Which number? All number?
No, it will be 0, 1, 0, 1, 1, 0, 0, 0.
0, 1, 0, 1.
The magnitude it will be 1, 1, 0, 1, 1, 0, 0, 0.
All right. 1, 1, 0, 1, 1, 0, 0, 0. Okay. We flip this number. We flip the positive number. Flip. Get the minus 39. We flip the positive 39 of one's complement to get the negative 39 of one's complement. What about the two's complement? What about the two's complement?
Plus 1.
Plus 1 point. Plus 1.
Plus 1?
1, 1,
Two?
1, 0, 1, 1, 0, 0.
Flip.
Okay.
Plus 1.
Okay, one by one. If we want to plus 1, we want to plus 1 to which number? This number, this number, this number, this
The
number.
one complement.
The
To the lowest bit.
The least
to the
significant.
lowest bit. Yeah, which
Add
number?
1, add
This
1 to
LSB?
the
LSB,
ones
LSB?
complement of
Yes.
To the
negative
first complement.
39.
Yes. We add 1 to
To the
the
first.
ones complement of the negative 39. Negative 39. Ones complement of the 39 lah. Okay, ones complement. Why 3? 1. What am I thinking? Okay, plus 1 here. So it will be?
1, 1, 0, 1, 1, 0, 0, 1.
Is that correct? We add 1 here or we add 1 here?
You add 1 to LSB.
We add 1 here? Yeah? We add 1 here, right? So it will be? One more time. 1 1
0 1
0 1
1 0 0 1.
1 0 0 1. Correct. Correct. Confused yet? Confused or not confused?
No, no, okay, clear.
No, okay, clear. Perfect. Okay. 1 1 0 1 1 0 0 1. Right. So from the original value here, which is positive 39, we flip once, and then we add 1. Or we just write from the right. Okay. Just follow until you reach the first one. In this case, the first one is at the LSB, and then you flip everything. 0 0 1 1 0 1 1. So you will get this same thing. Or you add 1 to this. Okay? Okay. Okay, everyone? Okay. Might
Yeah,
want
yeah,
to-
okay, doctor.
Okay,
Okay, okay.
right? Okay. So, if you have this number, 0 0 0 1, is it the same number in the previous one? 0 1 1 1. Okay. So this number is a ones complement. So what is the value? What is the value? This number is a ones complement. What is the value? What will be the sign here?
Positive.
It
Positive.
will be positive.
Which
Should
sign
be
is
negative.
positive? Sorry? Positive and negative. So the sign is positive because the MSB is 0. And then, because this is a ones complement, so we flip it back. Right? We flip it back. 1 1 1 0 1 0 0 0. Okay.
Do we need to, excuse me, doctor?
Yeah, we only calculate the
Oh, okay,
magnitude.
good. Yeah,
We only calculate the magnitude.
thanks.
Okay. And we get
Sensei, isn't it the positive number? No need to flip it.
yeah.
Just
Correct. Okay. Positive number, you don't need to flip. So this is positive. Okay.
positive 22, isn't it?
20,
23, sorry,
23.
23.
23, eh?
Yeah.
And then
16 plus 4 plus 2 plus 1.
yeah, 16, 4, 2, 1. Okay. So let's see if we can flip this, and we got minus 23. So 1 1 1 0 1 0 0 0. So from the MSB, we know that the sign is negative, and then we flip the remaining bits. 0 0 1 0 1 1, and we got this. Okay, 16 4 2 1. So it is negative 23. Right?
Yeah, right, doctor.
Okay, and then we check the two's complement. So let's just do the negative. Let's do negative. So this is 1 0 1 0 1 0 1 0. So if this is two complement, What is the value? We know that this is negative value. Then we write it again, 0, 1. We flip everything. Get?
Will be 86.
86, right? 86. I trust you. Everyone agree?
Calculator.
Yeah, I trust you. So everyone please agree. Just write a random number here. Okay, so seems like you are all good. Okay, I'm gonna stop sharing this one and back at this one. Okay. And then we talk about sign extension. Sign extension is a must when we move the 2's complement data to a bit register, like when we want to move from 32 bit to a 64 bit. Okay, like questions by Azlan, I think, just now. Okay, is it only applicable for 8 bit or it can go beyond that? The answer is it can go beyond that. And for the 2's complement, when it's positive, okay, we just add 0, okay, to the bits beyond the MSB and get the new MSB here. Okay. MSB
Sorry,
here.
Sensei, isn't you you are sharing something?
Hey, I'm not sharing.
Yeah.
Oh, sorry. Thank you. Okay. Oops. Okay. I repeat. Thank you very much. So the sign extension is a must when we move 2's complement data to a bigger data, like when we want to move from 8-bit to 16-bit, 16-bit to 32-bit, 32-bit to 64-bit. So for positive number, okay, in the 2's complement here, we just add 0 to the rest. Same goes to the sign magnitude and also to the 1's complement. Just add 0 to the additional bit here that is beyond the original MSB. Just add 0. And for negative number, just add 1 to the additional bits beyond the original MSB and get the new MSB here, which is. So the most important things to remember in the sign extension is to just copy the sign bit, okay, to fill the new high order bit. So this is called the new high order bit. All right. So that is all for sign extension. And then we will see about the offset binary. It's not this is not really used in the modern binary system, okay, modern machines. So the offset binary is a bias K representation, is a variation of the 2's complement, and we use K as the biasing value. Okay. You'll see the application later in the exponent of the floating point number. But beside that, it's also used in the analog interfacing that I think is not in the syllabus of this course, and also the access 3 code, okay, which is the original binary, you minus 3 for every number. Like if 7 is 111, the access 3 for 7 is 111, you minus 011, minus 3. That is supposed to be learned in digital electronic, but since we are not using this number system anymore in the modern days, so we exclude that in the digital electronic subject, right? Okay, it's just an intro. So the simplest, because we are using K as a biasing, right? So the most used ways to calculate the offset k is find 2 to the power of n minus 1. Okay, so if we are looking at 4-bit offset binary, the bias, okay, or the offset is 2 to the power of 4, n is the number of bit, minus 1, which is 2 to the power of 3, which is 8. So we just minus 8 to everything. Let me see. Oh, we just has bias 8 for everything. Like the 0, what's supposed to be 0 is 8. Okay. What's supposed to be 1? What's supposed to What's supposed to be 0 is now 8. Okay, because 0 plus 8, the bias is 8. What's supposed to be 1 is now 9. Okay, 0, 1, 1, 1, 0, 0, 1. Because we bias 8. So what's supposed to be 2 is now 10. Because 2 plus 8. And so on. Okay. And for the negative, okay, what's supposed to be minus 1 is now 7 because we add 8. What's supposed to be minus 2 is now 6 because we add 8. So that is the offset binary. Okay. So if we're talking about 4-bit offset binary, okay, you find the bias k, which is 2 to the power of n minus 1. Okay. And then you got k, and then you just add 8 to the number. Then you can represent the positive and minus, positive and negative of the number. All right, so this here is the comparison of the sign magnitude, 1's complement and 2's complement, and also the offsets binary. For the sign magnitude and 1's complement, we have negative 0, but it is not used. It is not used in the calculation. We use only 0, not minus 0. Okay, and 2's complement is the most used number system for sign numbers. Okay, for sign numbers in computer, because it is very useful to calculate arithmetic calculation, which is the subtraction. Okay? Like when you want to calculate 2 minus 1, we just have to calculate 2 plus the 2's complement of 1. And then you will get 2 minus 1. All right. Let's see if we have another slide here. This could be my last slide for today. Okay. So we are comparing the range of signed number system. Okay. For unsigned number, the smallest number is 0, and the largest number is 2 raised to n minus 1. So for 8 bits, the smallest number is 0, and the largest is 2, 5, 5. Right? For sign magnitude number, the smallest number is everyone?
Negative
127.
1 to 7.
1 to 8. Okay.
1 to 8.
Oh, yeah. 1
1
1
to
to 7.
1 to 7.
1 to 7, right?
1 to 7.
Negative 1 to 7 to positive
1 to
1 to 7. Okay. Minus 1. And then for 1's complement, it is the same, right?
The same.
Minus 1 to 7 to positive 1 to 7. And then for the 2's complement,
1 to 8 minus
One
1 to 8.
minus 1 to 8 to
1 to 8. Positive 1 to 8.
1 to 8, 1 to 7. 1 to 7. Positive 1 to 7. Because we have 0, right?
Oh yeah.
Because we have 0. Okay, so this is important. When is this important? Yeah. Well, it should be, there will be important time to remember this range when we do the implementation in CPLD later. Maybe, I'm not sure. But you need to know the range of the number so that when you design a system, you have to know when the calculation overflow. Okay. Because for sign number, you have to determine the bit. Okay. My system is 8-bit, for example. Okay, you said your system is 8-bit. Okay, my register can only hold 8 bits, but if your calculation is 130, then that will be overflow. So you need to know how to control the overflow when you do calculation, especially when we do calculation of multiplication. Okay, because when you have 8-bit, you multiply with 8-bit, you will get the double of the bits, 16-bit. So you need to know the range for some number system, sign number system. Because sign number system, we need to know the MSB at which bit. So you need to know the range. You need to know the number of bits in the system, and you need to know what number could be the overflow number. So let's say you are using number system, and you know that the MSB is the sign. So if it's 0 is positive, it's 1 is negative. When your number is overflow, so your sign bit will be at the bit number 9, for example. And then at bit number 8, let's say your sign bit is 0 at bit 8, and your bit 7, which is your MSB, is now, let me say that again. Let's say you're supposed to have a negative number, so your sign bit is supposed to be 1. But since you have an overflow, okay, your MSB turns to 0 due to the overflow, right? So now your number that is supposed to be negative is now wrong as positive number because the bit 7 is 0. Okay, well, you see the application later. See the application later when we do the arithmetic calculation, which is next week. Okay, so that is all for today. If you don't have any more questions about the previous chapters, that is just the revision for you. You can see my videos. If you want to learn about the revision, you can see my videos from the digital electronic class, or you can wait later because I will make the video for that. Okay? But it will be like a crash course for the video because in digital electronic we learn multiplexers in one chapter. We learn about gates in one chapter, for example, the Boolean, the K-map in one chapter. But in digital system, we just do the revision. So we will just touch a bit about it, except for the entered K-map and the hazard and also the FPGA part, okay, in the previous chapter. So you will have test 1. This is week 3. You will have test 1 at week 7. So we have another 3 weeks. And before you have tests at week 7, in week 6, we will do exercises, okay? So that you can prepare for the test. So we will do the previous test 1 together in class. Okay, everyone?
Yeah, okay, doctor.
All right.
Sounds
Okay, okay.
All right. So yeah, I have received the past year questions. So we will do that together in class. Right? Okay. So if you have no more questions, oh, don't forget about the milestone 1 submission today. Not today. This week until 3rd April.
Yeah, excuse me, doctor.
Questions?
Yeah.
Okay.
For milestone 1, do you need to write like a small discussion or a brief discussion?
As long as you could fulfill the rubrics. Okay, you see the rubrics, it says I have to check whether you understand what is like hierarchy, what is the modularity kind of thing. So you just have to do discussions on that.
Yeah, okay.
It can be brief discussion. You can elaborate, but I prefer to have brief discussion. Okay. And but not so brief, not like really brief. Just write a nice sentence on it, write nice paragraph on it, but don't put redundant phrases. Be brief but complete. Right?
Yeah, right.
Okay. Maybe you can use figure. That will be better to explain.
Yeah.
Sensei, is it that quarters naming system we cannot use numbers in it? Hello?
Yeah. I'm thinking.
Oh,
Yeah, you can't
Sorry.
use numbers to start the name.
Oh, to
No,
start the name.
to
You cannot.
start. Yeah,
at the
you can put
middle
numbers in
also
front.
cannot,
You have
right?
to put.
At the
That one I
middle
haven't
also
tried.
cannot.
Wait, no, can.
Can,
Can.
right?
But
Yeah.
my computer, when
In the
I
middle
change the
can.
name without numbers, then it works. But if have any numbers in it, then it don't
Oh,
know.
really?
They really got problem. I don't know why.
Oh.
Is it problem of version or something?
Oh, what version are you using?
13.
No,
Thir-
13?
I'm 14.1. Quarters 2
14.1.
14.1.
Oh, is that the problem in? Oh, not really a problem. It's just the rules for 14.1 probably. I'm sorry, I'm not sure about that.
Oh,
But since it's working without the numbers, then
yeah,
that's the.
for my computer cannot. Yeah, for my teammates don't know why cannot run the simulation at all. Yeah,
Even
but
you're
it
using the
will
same code. Even you're giving.
with
Oh,
the
really?
same schematic, it don't know why it cannot run.
What does the error says?
The error didn't go to that lah. Yeah, it stopped middle and then keep stopping. Wait until 1 hour also didn't change.
Really? Is it the
Yeah.
RAM of the computer?
My friend computer is better than me than mine.
Oh, really?
Yeah,
So it's not the RAM. What is it?
I don't know
Graphic
why.
card? Is it like turn black screen?
No,
Uh,
but it's just stop the compilation and also the stimulation.
Compilation can be done, but the simulation cannot be done.
Stimulation.
Yes, but it's a bit weird. But
Yeah,
Try reinstalling the
yeah.
software.
yeah.
Yeah, we are trying to do that also.
Okay, you can write that in the reflections because you have to submit the reflections too, right? You can write
Yeah,
that
yeah.
in the reflections and also in the in the report lah, as the the hardship that you went through. Right?
Okay, thank you, Sensei.
Okay, thank you everyone. ありがとうございました。またね。また来週。また来週 means see you next week.
ありがとう先生。
Thank you.
はい。
ありがとうござい
Thank you,
ます。バイ
Sensei.
バイ。さよなら。
Bye.
Thank you. Assalamualaikum.
Thank you,
Okay,
Dad.
thanks for coming.
Assalamualaikum.
Thank you, Dad.
For coming
Okay,
to my
Sensei. Arigato.